Okay.
Track the objective, read it for me aloud. Read it for me in a loud, clear voice. Stop. Go ahead, Gilbert.
Students will be able to compare gravitational pulls of objects in the solar system.
Great. We're going to be comparing gravitational pulls of objects in the solar system. What we're going to do is we have to do first guided notes, a demonstration, a teacher model, guided practice, independent practice, exercise, and close. Watch your mouth. Yeah, Miriam, sit down. Turn to the next page. Thank you. Every object in the universe with mass attracts every other object with mass. So for example, Diego's pencil box and the chair next to Luis have a gravitational attraction. However, most objects that we know of have no real, the measurable effect of gravity is very, very small. You have to be huge objects in order for there to be a gravitational pull that has significant impact. So, the amount of attraction depends on the amount of mass and of the objects and how far apart they are. Mass is the amount of matter an object contains and stays the same no matter the difference in gravity. For everyday-sized objects, this gravitational attraction or gravitational pull, repeat after me, gravitational, attraction, or pull, is vanishingly small. So even between humans, we're not anywhere near massive enough to have any real gravitational pull on other objects. It's very, very small. Very, very small. The larger and more massive a celestial body, the more gravitational pull it has on other objects in space. The less massive, which means the less mass a celestial body is, the less attraction it has towards objects in space. So, what we will be doing is we will be demonstrating the relationship between mass and gravity. We have here 3 different balls. One is a medicine ball, one is a black basketball, and one is a red rubber ball. So we're going to write all of those here. Red rubber ball. Black basketball. And orange medicine ball. Hold this. this. Hold this. Okay. So pass this one. Pass this one. Pass this one. So pass it around your table. So what can you tell the rest of your class about these 3 different balls? What can you tell about the 3 different balls? Jeremiah.
The medicine ball is heavy.
The medicine ball is heavy. Can you use a science vocabulary word in it? What does it have more of? Starts with N. Matter and mass. Would you say that this has a lot more or a little more than the other 2?
I would say that it has a lot more.
It has a lot more. Okay, so which of these 3 things do you think is going to have the most gravitational impact? What do you think? One of the people here, Rodolfo.
I think impact.
So which one of these do you think would have, so what we're going to be doing is we have this fabric that is like a really, really stretchy fabric, and we're all going to go over there, and we're going to drop each of the balls on top of this fabric.
Oh,
Which one do you think will make the most impact? Why?
Because it's heavy and if someone's under it, it's going to be off.
Okay. So, we're going to say the orange medicine ball. So, with this demonstration, what is our independent variable? What is our independent variable? Before we go over and do the demonstration, what is our independent variable? Richard.
Independent variable, independent variable, the thing that changes is the balls, and proper math, science term is the medicine ball's mass is greater than that of the other 2 balls.
Absolutely. What do you think we're going to be looking for? Where do you think we're going to be looking for? What do you think the dependent variable is going to be, based on what I described? Martin?
The fabric is going to be the dependent variable because it's where the ball's going to be landed.
What about the fabric? What are we going to be looking for on the fabric?
If it bounces on it, I guess.
We'll see. We're going to see when we get over there what we're going to need to do. So, what I'm going to ask is first Christian and Jocelyn and Jessica, if you guys can move this table, these 2 tables, like in between Yahaira's table and Agata's table. Go ahead and do that. Just move the table. Nope. And then, what we're going to do... Oh. Okay. What we're going to do is I'm going to call you over. What we're going to do is we're going to hold this taut. Repeat after me. Taut.
Taut.
And the word taut, the chair is over this. So, what we're going to do is, I'll wait for another. What we're going to do is when I call your table over, you're going to grab any part of this that you can. It should be enough that everybody can hold just a tiny bit. What's important is that we hold this evenly, so at the same height, because if one person holds it up here and one person holds it down here, what's going to happen?
It's going to be uneven. It's going to break.
It is going to be uneven. What do you think will happen to the balls, David?
They won't go the same way.
They're going to fall. And what we're looking for is we're going to look for dents in the center when I drop the ball. So what we're going to do is Jocelyn's table, Henry's table, and Richard's table come first. And then Jeremiah's table and Diego's table. So what I want to do is grab...
Now stay out there.
Break them. Do not want to speak. Okay. We're gonna need some people over here, and then Henry's table, Martin's table, and clap. Okay. So, what you're going to do, Rodolfo, please get down. Clap. If you cannot follow directions, you can go to your seat. Edward Lopez, I'm looking at you. You ran over there. So, I need...
Okay. Are we talking?
Okay.
My YouTube channel. My YouTube channel. Also on Instagram.
Kimberly, I just told Rodolfo. Please get off. Okay, so this needs to be held taut, and your hands need to be on the edge. If your hands are not on the edge, it's going to be a problem. You are not going under. You are not going underneath this for any reason, because trust me, it will not be good for you.
Oh yeah.
Okay. So we're gonna start. Okay. Again, I don't see your hand. I don't see your hands or a pencil. Okay. The first one.
Not so hard.
You don't need that.
Stop.
When I say
Oh, sorry.
when I say hold it evenly, I want you to hold it evenly so we can just watch. Does it do much as far as that? Yeah. Not really. You could see a little bit of it. And then you do it again and sit down. This one. A little bit of a dent, but not much.
No, stop putting it down.
They're pulling up the.
Hey, David, bring it down.
Now.
Henry,
Rodolfo, you guys are not holding this evenly right now. What do you? No.
No, don't do that.
Let it.
I'm gonna hit the feet.
So, what do you notice? What do you notice about this?
leave it there.
What do you notice, Edward? What do you notice about this? What was the difference between this one and the other? Edward, I'm asking you the question.
Oh, me? Oh,
Yes.
what do you mean? It's like heavier?
It's heavier? How can you tell?
Because it's all the way like at the bottom.
Yeah, because the dent... I'm sorry. Because the dent is showing us that there's an effect of mass and on gravity. So now you've made this side. Yes, David.
Oh, I did it?
Okay, you are all going to hand the lycra, which is the fabric, over to Cynthia. So hand it to her. And
Not pushing me,
19, 18,
You okay, Cynthia?
17, 16, 15, 14, 12, 11, 10, 9, yeah. 9, 5, 4, 3, 1. this, please, Louise? Put it away, please, Rudolph. Okay. So which ball did end up having the most gravitational force? Which ball did have the most gravitational force? Diego. Can you put that in a complete sentence, Diego?
The ball that had the most gravitational force was the orange medicine ball.
The medicine ball? The medicine ball had the most gravitational force. Why? Why? Fernando. Can you use the word that we used earlier? It has, yes, next, Richard. No. What's the word? It is heavy because it has a lot of what? Yes. The medicine force had the most gravitational force because it had the most mass. Of all three. Now this next question, what I'm going to have you guys do is I'm going to have you talk, I'm going to read the question and I'm going to have you talk with your teammates and really think about this. So we have two parts of the model. We have the balls themselves and we have the lycra. Repeat after me, lycra? Lycra! And the lycra was the kind of fabric. What do you think this model was representing, and what do you think both the lycra and each of the balls represented? And what were the advantages and disadvantages of the model? You have 30 seconds to talk with your teammates. Go ahead. It's part of Why did I have you do it today?
I think the model shows how mass and matter.
Why did I have you do this? The objective, what at least talking about this week. What do you guys think? What have we been talking Alright, so what was the model representing? What was the model representing? Henry, what do you think?
Comparing gravity.
Okay, so what were the balls, do you think?
Objects in the solar system.
Objects in our solar system. And what do you think then the lycra was? What do you think the lycra was supposed to represent? Richard?
The Earth's gravitational pull and the gravity.
It was supposed to represent something else, bigger than Earth.
Okay, the field, universe.
Close. Jeremiah?
The solar system?
Yeah, it was supposed to represent the solar system.
I thought they were the
What?
same thing. Universe and solar system.
The universe is much, much bigger than our solar system.
Oh,
Our solar system is so small. Okay, the model was representing the galaxies bigger than our solar system. Was representing the gravitational impact of objects, of celestial objects in our solar system. The balls in our solar system. Like that. advantages, we're only going to write about the advantages. We're going to talk about the disadvantages, but for space purposes. What was the advantage of this model? What did it show? What did it show? What was I trying to get you to understand? Martin?
Well, this is like sort of the message that I also feel
Yep,
like.
sure.
Like asteroids, they have the same shape as the ball, so
Yep.
they're like a sphere.
Yep. Okay, so one of the advantages were the shapes, because like planets, moons, some asteroids are the same shape as the balls. That's a good thing. What else did it show? What did it show with the medicine ball? What did it show? Cynthia? It could show the sun. Why? Why was I having you do this? What was the difference between the black basketball and the red rubber ball and then the orange medicine ball? David?
That they all weighted the different.
They had different masses, and what did it show?
It showed that they made different things in the solar system.
Close. Jeremiah, add on.
It shows that depending on the matter and the mass, the matter and the mass in the celestial body makes the impact of the gravitational pull.
So the more mass there is, the more what there is.
Gravitational pull.
Yeah, if you guys notice when you were holding it, when I dropped that medicine ball, did it become harder to hold on to the Lycra? It should have. Now, there were so many of you that it wasn't that much of an impact, but you could literally see it. You could literally see it. The ball created this dent. The advantages of the model was that it showed that the more mass an object had, the more gravitational pull it had. Take the next 40 seconds to make sure that you have that written.